Hello, and welcome to the Human-Computer Interaction Laboratory at the University of Maryland at College Park. My name is Richard Chimera, and I'm a full-time researcher and lab manager here. Today I'll be showing you 3 research projects that we've done in the last year, all relating to online directory browsing, in which I participated or supervised the research. These 3 projects all contribute to Visor, our grand vision to deliver to users a set of interface tools with which to visualize, navigate, and manipulate large information spaces. Top-down tree maps display a tree in a space-filling manner while maintaining a clear representation of the tree structure. A recursive algorithm implemented by Ram Naresh Singh partitions a rectangular screen space into rectangles whose area is proportional to the size of the directory. For example, the directory called map1 is the biggest rectangle on the screen and therefore represents the largest directory in this tree. The children of the root level node demo dir are backup, dir, lex, map, and tree. An additional attribute of the top-down tree map is that leaf directories extend all the way to the bottom. Now look at a traditional tree display. See how much space is wasted with edges and the spaces between the rectangles. However, a top-down tree map collapses this wasted space and also retains the directory size information lost by the traditional display. Navigation is therefore made obsolete. There is no CD command. To see the contents of a directory, users simply click on the button represented by the directory name to see the contents appear in the text panes below. I can immediately see the contents of a directory 4 levels deep by clicking on the button and seeing the contents here. Directory contents output alternate between the 2 text panes. We conducted an experiment comparing the top-down tree maps with the Unix command line interface with 10 computer science graduate students using a within-subject design. Tasks contain questions about directory sizes, directory contents, and directory structure. All tasks but task 5 showed a statistically significant speed advantage for top-down tree maps, likely due to the awkward navigation and lengthy and error-prone typing in the Unix command line interface. Enhancements that we're considering include color coding of the rectangles for attributes such as modification dates, file types, or number of files in a directory, and also the capability to zoom in on small directories. Value bars are an information visualization and traversal tool for multi-attribute listings and tables. Value bars can be thought of as a one-dimensional tree map providing a proportional view of an attribute's values. I have implemented a value bar for the Unix directory listings in the Open Windows X environment. What you see here is a Unix directory listing of 189 files and 2 value bars on the far right. The value bar labeled S stands for file size. The value bar labeled Y stands for file youth. Value bars provide a WYSI-WIL interface. What you see is what is large. The biggest box in the size value bar represents the largest file in this directory. Notice there are other very large files nearby. The biggest box in the youth value bar represents the most recently modified file. Here's the most recent, and here's another very recently modified file. The advantage of value bars is that it makes it easy for users to find items with large attribute values. Users can see the local detail within a global context, which is a very useful feature for interfaces to large information spaces. More formally, the height of the size value bar represents the space used by all files in this directory. Each file is assigned a height for its value bar box that is proportional to its size. Value bars also share graphic characteristics with the scroll bar to aid with user familiarity. The visibility marker, this dark black line, performs exactly the same function. It shows which boxes listing items are currently in the text pane. Notice each value bar is completely independent. This independence is best shown when I use the normal scroll bar to scroll among the listings. Notice how the visibility markers differ in height and coverage independently between the two value bars. Although it takes a little practice to gain familiarity with value bars, a usability study suggested that with 10 minutes of training, the main features of value bars were used efficiently. That is, seeing an attribute value distribution overview while maintaining the original sort order is helpful. Seeing many attribute value distribution overviews simultaneously is helpful. And jumping to interesting items is also helpful. Another tool to visualize contents within a single directory is called Dynamic Queries Directory Browsing. The objective here is to focus users' attention on just those items that satisfy a combination of selection criteria. We have implemented many versions, and I will be showing you 3 today. One called Asterisks, one called Color, and one called Expand Contract. What you see here is the color interface. In the top pane is a Unix directory listing. Below that are 2 sliders, one for file age and one for file size. As I slide the size slider, files that are not bigger than the value in the slider turn to a tan color in order to de-emphasize them. There are many ways that you can use color coding in a more elaborate manner than this interface does. For example, many colors could represent the different ranges of values, perhaps blue for very small files, green for medium files, and red for large files. In our second interface, called the Asterisks interface, files matching the combination of selection criteria have an asterisk in the leftmost column. All implementations that you'll see today allow users to set whether an attribute will actually be used as the filter. This is done via the yes, no toggle buttons. And also whether to use less than or greater than as the operator for the slider. In this interface, any sort of graphical mark could be used as the matching signal instead of the asterisk, or you could underline file names, etc. The Expand Contract interface actually removes and inserts files into the list as the selection criteria are changed. Early users complained the display was too frantic and confusing, so we modified the behavior to what you see now, which is that the update of the files only occurs when the mouse button is released and not as the slider is actually being moved. This brings to mind another enhancement we're considering, which is the use of sound to indicate when a file is toggled in or out of the display. That would be especially useful in this interface, since the sound could be made as the slider is sliding, but the update to the display is only made when the mouse button is released. There are many ways to choose attribute values with which to query. Right here you see normal sliders. There is also the concept of a 2 drag box slider, where we would have another drag box here in order to create a range of values that does not always extend to the end point. There's also the concept of scrolling lists, substring matches, and anything else naturally related to the attributes of the domain. We conducted an experiment to determine which interface allowed faster completion of browsing tasks and had higher subjective satisfaction. 18 Office professionals with computer experience participated in a counterbalance within subject design. The directories used were similarly structured, but not identical, to eliminate memorization. 2 sizes of directories were used: small, containing 30 files and involved no scrolling, and medium, which involved 60 files and required scrolling. Statistical analysis revealed that in the medium directory size condition, there were significant differences favoring the Expand Contract interface over both the color interface and the asterisk interface for many tasks. The results practitioners may take away from this research is that reducing the items to which attention is focused aids in finding interesting items. Also, that the dynamic nature of filters put the user in control and allows for discovery of interesting relations among the files. Finally, the interaction is intuitive, there is no syntax to be memorized, and the results are displayed within the context of the domain.